My name is Mary Ann Dickinson. I'm the President and CEO of the Alliance for Water Efficiency, and we're here today to talk about innovations in efficiency, specifically focusing on cooling tower management, managing and optimizing water efficiency. And this is part of our showcase series on innovations in efficiency, where we feature the products and programs of the business members of the Alliance for Water Efficiency that should be of great interest to those of you in the water utility world who are planning and promoting water conservation programs. So this particular topic we chose because of the great interest in cooling tower management that we see among our membership. The webinar will be 60 minutes today. We will allow time for questions. We are hoping to have at least a 10 to 15 minute time block for questions. As you probably know if you're hearing my voice, the audio is either through the telephone or with your computer microphone and speakers. So if you're not hearing my voice, hopefully the slide will clue you in on how you can connect to the audio. As I mentioned, the webinar phone line is muted for all the participants. Because we are recording it, we'll have instructions at the end of the webinar for where you'll be able to find the recording if you would like to listen to it later. But we do want you to participate. Just because the line is muted doesn't mean we don't want your questions typed in throughout the webinar as they occur to you. We will be answering the questions in the order that they have been received, and the speakers are all looking forward to the discussion that we'll have. So as I mentioned, we have launched this Innovations and Efficiency Showcase series to provide an opportunity for our members, our water professionals in the water utility world, in business and industry, to learn about the products and services that are available in water efficiency from our membership. And the objective is to share this efficiency information, especially the latest and greatest, newest, ahead of the curve topics and technology improvements that you might not otherwise be aware of if you weren't following this topic really closely. So in this series, which is featuring a wide range of programs and products, we're looking at innovative and emerging technology and services, new approaches to dealing with the types of water efficiency related challenges that we face, and especially giving case studies of how these new technologies, programs, and practices have been successfully applied in the field. And that's what, of course, you're going to hear about today. All our AWE business and industry partners are eligible to participate, and we will be continuing this series with new webinar offerings in 2016. Let us know if you'd like to participate. So today's webinar is going to focus on this great topic of cooling tower management, and we're very pleased to have the following speakers with us today. Rick Alvarado, Cooling Tower Program Director for Denver Water, Sean Bray, the Business Development Director for TERLYN Industries, Scott Whip, the Regional Manager and Principal at Phigenics, and Kellen Utecht, Director of Sustainability at Phigenics. And these great speakers will be giving you lots of information and hopefully spur your questions and curiosity about the technologies and practices that they will be discussing. So the purpose is to stress that cooling tower management is an important efficiency strategy. Yes, there are savings, significant savings that you can achieve in both water, wastewater, energy, and money. And we will be talking to you about all of that today. Businesses that are offering incentives for cooling tower management, they know that utilities who are providing these incentives know that they can capture these savings if they do these programs comprehensively. And so what we want to outline for you today are the strategies and solutions that are available to you, especially to the facility managers, to make operations more cost-effective, safe, and sustainable. And so if you're a water utility here, we also will learn a lot from Denver Water's example of how their incentivizing cooling tower management has provided lots of benefit for their system. So these rebates and incentive programs we'll be talking about in the webinar, and there will be lots of opportunities to ask questions about how those work during the discussion period. So my last slide is just what is a cooling tower? And this is something you'll get lots of discussion on from our speakers. They're used in large building Central cooling systems. The purpose is to remove large amounts of heat from the air and equipment. There are large energy and water users in these large buildings, mostly office buildings. And they're also used for refrigeration, cold storage facilities, dry cleaning, medical equipment, manufacturing, and industry. In short, cooling towers are everywhere, and better management of those cooling towers can yield very substantial savings. The consumption of cooling towers has been shown in the EPA Water Sense at Work document. You can see the end uses of water in office buildings. The cooling there is the red pie slice. So 28% of the end use of water in office buildings is cooling and heating. In hospitals, it's 20%. In hotels, it's 12%. It differs from sector to sector, but it's a substantial piece that needs to be paid attention to. So our first set of presentations will be Denver Water and TERLYN, who is working with Denver Water, and they'll be talking about developing a cooling tower water conservation program, and our first speaker will be Rick Alvarado.
Well, thank you very much, Mary Ann. It was quite informative. This is my very first webinar. I'm excited to do it. It's kind of nice to not have all these faces looking back at me. I understand that we have some of the finest minds in the Alliance for Water Efficiency, and I'm excited and a little nervous to be speaking to you, but you all must be very excited to be just from the sound of my voice too. So I am going to be speaking to you a little bit about our cooling tower performance rebate program. Big question is that we get quite often is, why does Denver Water even care? Well, we want to help you reduce the water and energy costs to all of our customers, whether it's in cooling towers or irrigation systems or what have you. We want to help you reduce operating costs, water treatment and chemical costs that are all involved. And a big one is just to reduce the wastewater discharge that's gone into a lot of our rivers and things like that, and saving potable water for our expanding population. Here in Denver, we are just growing by leaps and bounds. The construction industry is doing quite nicely here in Denver. This all began with the drought response back in 2001. We're searching for ways and new programs to develop and save water, and our commercial industrial program was in place already, and we decided to branch out a little bit more and kind of focus on the cooling tower performance rebate program. At that time, you had to meet very high criteria. You had to save 1 million gallons of water per year, and we only paid maybe like $12 per 1,000 gallons, and it has since developed. We've gone down to 500,000, then eventually to 200,000, and now we're at 50,000 gallons required savings to be eligible for a rebate. Next slide, please. Our cooling tower performance rebate now is 50% of project cost, or $40,000 towards improving your efficiency in your tower, or $18.50 for every 1,000 gallons of water saved over a 1-year period. This is decided whichever is less. So as I said, this meets a minimum requirement of 50,000 gallons. This has allowed us to really get even a lot of the smaller towers involved. At the high requirement, it really narrowed our involvement. Next slide, please. Easiest way to save water in cooling towers, of course, is to increase the cycles of concentration. This is the quickest method that we've seen for water conservation. There's no downtime, but you just want to be sure and consult your chemical supplier. Make sure that whatever path you choose, that it is not going to do any harm to the tower or the environment, and that is your first decision. Next slide, please. Some of our requirements is simple. We require that you have makeup and bleed meters installed. This will help us to calculate how many gallons of water you're actually using in the tower. We need a conductivity controller. It's something that's actually controlling the conductivity in your tower. And then we develop a communications package. This is something that we develop between the customer and ourselves so that we are getting these makeup and bleed readings on a timely manner every month. Next slide, please. Why a performance-based rebate? Well, we wanted to get away from the large contracts. We had a large contract every time that we did a incentive contract with a certain industry. It was a contract, and it was kind of scary to some people. So we decided that since it is a one-time payment, and whether you get the savings or not that we predicted, if you don't reach your savings, you're going to get paid for the savings, whatever you actually did save. So it is not just for cooling towers only. We are branching out. We can do performance rebate on car washes or whatever it is. The main point is we don't want to see you leave money on the table. And it's easier sell for the vendor. They're able to work this into their bid and maybe help them push a customer over the edge into changing. Next slide, please. Here's an example of an 800-ton tower that went from 5 cycles to 8 cycles. They saved about 338,000 gallons per year. We paid them about $6,253 in incentive. Next slide, please. Now, regardless of what you do, we really are not all that interested in how you do it. We do make sure that whatever you're doing has been proven, and that it's something that we actually want to get behind. So whether it's traditional chemical treatment or green chemical treatment or some type of physical water treatment, if you're saving water, please look and get in contact with Denver Water, or hopefully in any utility that you might be involved in. Check out, next slide, please. Here's an 800-ton tower that saved 707,000 gallons by going from 5 cycles to 40 cycles. Very well could have been the TERLYN product. That paid them $13,000 in incentives. Next slide, please. So, develop a plan of action. Be prepared to answer some of these questions. Can you save 50,000 gallons? Do you have water meters, sub-meters? If not, see if your utility can provide it. Denver Water has a used meter program that we've taken meters out of service and put them and refurbished them, made sure that they work, and these all work quite well as sub-meters. So some of the information we'll need is how many cycles you're at. Well, how many cycles do you want to get? What is your set point currently? How many days of operation do you run? These all help us to develop a calculation, determine how much water your tower is currently using and how much you can save. Next slide, please. If you're in Denver, you can, or any of our service area, which it's quite large, you can get on denverwater.org and navigate to the indoor water savings incentive programs, cooling tower, and then you complete the application form, and then someone will be in contact with you to schedule a cooling tower audit. Once we're there, we'll determine the best date to begin your monitoring year and provide the way for you to send in your makeup and bleed readings along with any receipts for project cost. Next slide, please. City and County in Denver has a evaporation credit program. Not all cities have this, but this allows the city to give you credit for water that's actually being evaporated from the tower, not going down into the sewer. So, next slide, please. All in all, Denver Water is committed to helping your business save water, whether it's in the cooling tower incentive program or any type of water savings project that you may have in your facility. You know, we are always open to be creative and find a way to reward you for your attempt to save water. Next slide, please. So, I hope that you have some questions for me. Here is a advertising campaign that we're currently using. These are actual works of art. Is that you can't make this stuff. These are all been mounted on a lot of the bus stops around town, and they're been well received. So thank you for your time, and a big thank you to Mr. Sean Bray, who invited me to come along and share some information with you all. And with that, I'm going to send this over to Mr. Sean Bray of TERLYN Industries.
All right. Hey, thank you very much, Rick. Appreciate you being here. Yes, my name is Sean Bray. I'm the Business Development Director for TERLYN Industries, and my main focus is to introduce and educate individuals and companies about the concept of cooling tower water conservation. Here at TERLYN Industries, our focus is performance, efficiency, and sustainability, and in that particular order. I'm sure Phigenics is going to back that up when they speak here in just a moment. Next slide, please. A comprehensive water treatment program is utilized on all to control the major problems that can occur. A scale inhibitor is used to control scale formation. A corrosion inhibitor is used to control corrosion. And a biocide is used to control biological growth. So now, all water treatment programs use similar products to control corrosion and biological fouling. It's the scale inhibitor alone that determines the amount of bleed-off that's required to maintain system integrity. It's the scale inhibitor that allows for water conservation in a cooling tower. Next slide, please. So, you know, all scale inhibitors work by increasing the natural saturation point of cooling tower water, increasing its ability to hold hardness in solution. So, for example, if the incoming water is 100 parts per million hardness naturally, and you add a typical scale inhibitor, you would increase the water's ability to hold hardness to 100 parts per million, or you increase the saturation point 3 times. The TERLYN scaling inhibitor is tested and proven to increase the saturation point to the highest levels possible while still maintaining complete system integrity, higher than any other product available. Next slide, please. And it's not achieved through, you know, rocket science or magic. It's pretty simple. The standard scale inhibitor molecule has a bonding strength of 100 to 1. The TERLYN scale inhibitor has a bonding strength of 3,000 to 1. It's pretty much like how you might describe the difference between Elmer's glue and super glue. They both essentially do the same thing. One just does it better than the other. Next slide, please. So here's an idea, a way of looking at the operating range. What you see here, you know, if you're operating a cooling tower without any water treatment program, then 100% of the wastewater is wasted. By implementing a traditional chemical treatment program, you are actually, in fact, implementing water conservation because you will reduce the wastewater down to 50 to 25%. But at the same time, you're creating a very narrow window in which to operate within and achieve complete system integrity, which is demonstrated by the area that's in green. That's what we call our sweet spot. And if you look at the graph down below, which is the TERLYN treatment program, you can see that our sweet spot, our operating zone for, you know, to achieve complete system integrity is very, very broad. And you achieve the most water conservation available, reducing wastewater down to 5 to 2%. Next slide, please. Now, this is what we brought to the table when Denver Water asked us to participate in their study back in 2008. Next slide, please. This is an aerial view of the actual building that we were on. RTU3 there on the right, that is TERLYN. There were 4 rooftop units, and each RTU is an independent system that serves a quadrant of the building. So all the units shared equal load, units on the same rooftop, installed the same controls in each unit, so the results came down to water treatment only. Next slide, please. So all units were allowed to run for a year. What was being mainly tracked was water consumption, 2 sets of corrosion coupons per unit, and bacteria counts. Next slide, please. So when the results came in, corrosion coupon results is what you see on your screen right now, all within industry standards. The TERLYN program in green just had a little bit better readings in mild steel and copper. Next slide, please. Bacteria test results, again, all within acceptable industry standards. Next slide, please. I know I'm blazing through these, but if you have any questions on it, by all means, in the Q&A. This is the total water consumption, and hands down, in the green, the improved chemical technology, which is TERLYN, we conserved the most water in both makeup and blowdown. Next slide, please. So I'm happy to say that Denver Water asked us to stay on that building. We're still on that building. It's a small tower. It's under 1,000 tons with low demand load. But over the years, we've helped them conserve over 2.1 million gallons. And we hope to be on that building for many years to come. Rick, advance the slide, please. So looming in the background while this was going on is this Executive Order 13514, which requires all government buildings to reduce their water use by 26% by 2020. And GSA is basically the government's landlord. They were being challenged by this. I mean, they had addressed the low-flow toilets, you know, different aeration, irrigation, and they were being challenged. So they caught wind of what Denver Water was doing. Next slide, please. With their cooling towers, and decided to put it to the test themselves. So they conducted their own study, very similar to what Denver Water did, through their Green Proving Ground program. And you can see some of the organizations involved in that on your screen. Next slide, please. GSA discovered the same thing that Denver Water did, that TERLYN's program reduces the water waste the best, and also maintains complete system integrity. But they didn't stop there. GSA decided to vet it out even more, and they took the TERLYN program and placed it on 4 more buildings and tested that out for another year. And the results came back in. They proved what they had found in Building 67, which backed up what Denver Water was doing. Next slide, please. And now GSA is expanding the use of the TERLYN program to more of their mission-critical buildings. And we're talking like the National Ice Core Laboratory, NOAA Data Center, EPA. These buildings are the headquarters for our nation's critical operations. Next slide, please. This is an overview. This is not all the buildings that are on the program at the Denver Federal Center, just some of them, so you can get an idea. You know, like Building 67, the one that we started with first, has been on for over 44 months, and 4.2 million gallons saved. Cesar Chavez, the next one on the list, they've actually now achieved a gold LEED certification. But go ahead and scan your eyes down to the last one in the list, Building 810, and you see that it's only been on for a month. And this is to demonstrate it does not take that long for the program to start generating water savings and utility savings. The average water conservation savings at the Denver Federal Center is 60%. Next slide, please. Now, once we started getting into the project with Denver Federal Center, the folks reporting data back to us and back to others that are collecting the data started to notice that there was a significant decrease in energy demand on the system. They asked if we had something to do with that, and the answer is yes. Not only will the TERLYN program reduce significantly the amount of wastewater and maintain your system with complete system integrity, but after the program, the product is able to be in the system for an extended period of time, it will start to decrease the scale throughout the entire system. And as you can see from this chart, it does not take very much scale to increase energy demand on a system. So we're just slowly backing that down and actually helping to conserve a significant amount of energy as well. Next slide, please. So the benefits of the TERLYN Cooling Tower Water Conservation Program, as proven by the case studies with GSA, Denver Water, and several others, is that it achieves complete system integrity. So there's no scale, no corrosion, no biological growth. It's the highest possible cooling tower water conservation available. You get the utility savings. Our program, it pays for itself from the water utility savings and puts significant water and energy savings back into your operating budgets. And over time, you will also see decreased energy consumption. So you save water, you save energy, you save money, you save time. Next slide, please. So I'd like to thank you for allowing me to speak today. Shout out to Rick Alvarado, Denver Water. Thanks for joining me on this presentation. I'll leave you with this. If you have a cooling tower, or you know somebody who does, please share this information with them. And if you have implemented a program or are looking at conserving water in your cooling tower, and perhaps you think you've done all that you can, I'm telling you, you're probably leaving money on the table, and there is more water to be conserved. Take a look at the program, and I appreciate you having me here today. I'm going to hand the microphone back to Mary Ann. Thank you.
Okay, thank you very much, Sean and Rick. And if you have questions about their presentation, what you need to do is go to the dialog box that's in the upper right-hand corner of your screen. If you see a little orange square with a white arrow in it, and you click that to open it, you'll see that there's a place that you can enter your questions in the box down below, and you can begin to think about questions you might want to ask them. We'll have this whole question period near the end of the webinar. So at this point, we'd like to move to the second part of our presentation, pioneering our portfolio approach to cooling tower water management with Walmart. And Phigenics is one of our members, and we're going to hear from Scott Whipp and Kellen Utecht about the Phigenics program.
So the purpose for our presentation today is really to provide an overview of the approach for how to safely and efficiently manage water across the portfolio of facilities. Now for this, we're going to use Walmart as the case study, and they have demonstrated leadership through their investment in time in seeking to optimize this program. And through this, they've been able to save 660 million gallons of water and $4.4 million. But understand, this can be used by any organization, whether they have 2 or 1,000 facilities, and whether these are on the same campus in the same city or across the U.S. for that matter. As was on the previous slide, I'm joined by Scott Whipp, who's a regional manager and principal at Phigenics. Scott has 25 years of water management experience, first with Nalco and then with Phigenics. And he runs the region down in Virginia, Tennessee, North Carolina, South Carolina, and Georgia. He has a number of clients utilizing this portfolio approach. I've been with Phigenics for 2 years. Previously was with the Sustainability Consortium in WWF Turkey in corporate water stewardship, and am the account manager for the Walmart account. Phigenics is an independent water management company who was founded to help facility managers optimize the efficiency and cost and improve the safety of their water systems. Now, we define independence in that we don't sell water treatment chemicals or equipment. Where what we do is seek to partner with organizations to develop their own water management program goals, objectives, and then independently verify and validate performance towards KPIs. Our primary service offering is a 4-box water management program, which I'll touch on in the next slide, but we also operate 2 CDC Elite certified water testing laboratories where we're able to test for water safety and water efficiency. Next slide, please. So before we get into the actual case study, just wanted to touch briefly on something that we are always wanting to say and put in the forefront of all discussions, especially around cooling towers. And that is, if you're building water systems not safe, then it's not sustainable. And everyone has budgets, and budget allocation for managing water in most C&I buildings is spent on 4 things: efficiently using potable water, efficiently using utility water, safely using potable water, and safely using utility water. And all 4 of these are linked. You cannot completely separate the boxes. And there's 2 events that happened this summer that underlines the importance of this. The first is the ANSI ASHRAF Standard 188, Legionellosis, Risk Management for Building Water Systems. And the second, well, this standard was passed on June 26th, and then the second, if you go to the next slide, was the unfortunate Legionnaire's disease outbreak that happened in New York City. I'm sure most of you, if not all of you, have heard about this. Now, water is used to save energy, and cooling towers and evaporative condensers exist to save water. But savings without safety nullifies any benefit. And really, these deaths are a failure of public awareness and water treatment. Now, I was at a conference not too long ago, and I heard a defense attorney claim you should expect to find Legionella in 30% of your cooling towers. And I can tell you from experience, any well management program should be nowhere near 30% positive for quarterly validation tests. Next slide, please. So what happened and what was the immediate response in New York? Well, the New York City Health Commissioner, issued this order. And the order directed facility owners and managers to do three things: disinfect all your building cooling towers, keep records and manage data in regards to this, and work with consultants that know how to implement ANSI ASHRAF Standard 188. They put P in there. It's no longer in proposal stage. It is a full standard, and also CTI guidelines. Next slide, please. Following this, the City Council then passed a bill aimed at limiting future Legionnaires outbreaks. And I just want you to look at that. It passed 42-0. This was a unanimous vote. I looked online, and there wasn't a lot of unanimous votes taking place by the City Council there. But if you look through what's being required of building owners and managers, you see that many of these items are also required within, not to register all towers, but are also part of ANSI ASHRAF Standard 188. So to develop and implement a maintenance plan in line with current engineering standards, this really does tie to the standard that was passed. Next slide, please. So what is ANSI ASHRAF Standard 188? The title is Legionellosis Risk Management for Building Water Systems. And I'm not going to go too deep into this because I want to make sure we leave plenty of time for questions and the case study. But Dr. McCoy, Chief Technology Officer of Phigenics, did an emergency presentation on this for Alliance for Water Efficiency at the end of August, and you can go in and learn more about it. But this standard affects 5 million buildings, and if you look in the list, it highlights cooling towers or evaporative condensers. So proper implementation and independent oversight of these programs really does help facility managers protect human health and safety and defend themselves against claims of negligence. Furthermore, the lessons from New York underscore the importance of proactive water management and the importance of facility owners and cities to partner to help prevent these tragedies. Next slide, please. So a defensible water management program for a portfolio of facilities does include, the design and implementation of ANSI ASHRAF Standard 188. And the great thing about this standard is it provides a framework for really how you can also drive efficiency gains through your portfolio of facilities. So as a reminder, really going to be providing an overview of the process for how to safely and efficiently manage this water use. And safety is a big key part of it. So next slide, please. Like many organizations, Walmart in this instance decided to use water cooling for certain stores because it saved energy and helped achieve energy efficiency goals. They've reported publicly that these stores save about 35 to 42% in energy savings. Next slide, please. But in 2008, there was about 180 stores with 305 cooling towers spread out across the United States. And what they found is they had a fragmented approach, which was driving higher costs and water use. What do we mean by a fragmented approach? Well, there was lack of supplier oversight, 15 different suppliers of water treatment services, each with their own vendor report forms with different KPIs than Walmart's, inconsistent chemical strategy, then their own proprietary chemical feed equipment that was not interchangeable if they wanted to bring a new supplier in. So if the old supplier went out, everything new had to come in. And so this also resulted in inadequate and inconsistent service. So to further amplify, and one of the things that usually drives innovation is when you might not have as many resources on site, there was no engineering support at each of the stores. So they really had to get innovative about the ways they wanted to approach this problem to lower costs and become more water efficient. Next slide, please. So what are some costs of operational efficiencies if you have a fragmented approach? And this is true for any organization. You have excessive water consumption, decreased energy efficiency, and you're probably using more of your labor operations than need be. I want to touch on where it says tower shutdowns. Now, in a retail setting, if a tower shuts down, it's going to result, or in this case, evaporative condenser, it's going to result in a loss of inventory. But think about a hospital setting, where they use cooling towers for comfort cooling, and it's during a critical surgery. There's times and places where if you lose that cooling and you lose, the removal of heat, it can negatively impact performance and customer service and cause major issues. So, next slide, please. So recognizing that there's these costs, they thought there had to be a different way. And so looking back over this experience, and we've had the opportunity to work with Walmart for since 2008, and really identify what were the key steps along the way that could be used by others to do something similar. And the 7 steps that we've identified were: 1, gain leadership buy-in. That's crucial. 2, develop a cooling water management team. 3, develop a benchmarking program. 4, create a performance specification. 5, develop verification and validation strategies. 6, make it smart. And 7, celebrate and communicate success. So now I'm going to speak a little bit more broadly about each of these steps, and then come to what were the ultimate benefits to Walmart from doing each of these. Next slide, please. So the first one is to gain leadership buy-in. A lot of different parts of the organization, and so one piece. So it's very important that there's a attractive return on investment to make it worth the time and effort for the organization to take something like this on. And in order to calculate an ROI, and a lot of businesses will calculate it a little bit differently, you have to look at how are we expanding the life of the capital that we've invested in. How much water are we reducing usage, energy we're reducing usage, chemical that we're reducing usage. And when you bring it all together, you can calculate that ROI. And then second, alignment with existing corporate sustainability goals, being proactive stewards of water resources, achieving energy efficiency, promoting a healthier environment. And really, by being able to do the portfolio approach, you can roll up all of that data and then effectively report out to disclosure programs as well. Next slide, please. And once you gain that leadership buy-in, you got to develop that water management team. Now, this is also mandated in ANSI ASHRAF Standard 188. And more specifically, it's got to be a cross-functional team with the accountability and responsibility for designing and implementing the program. So in our role, we work closely with the program champion to help facilitate and evaluate the program, but it's the team that makes the decision. And each of these team members bring their own objectives when it comes to water management. For some, it's safety, and they would like to have as much flow as possible. And for some, it's reducing water use, and they want to reduce flow where they can. At this time, Scott, as an RM, will you share a little bit more about the importance of water management teams, especially when managing a dispersed portfolio of facilities?
Yeah, just checking, Marianne. Is the reception okay?
Yeah, it is.
I can hear you well, Scott.
Okay, just double checking. I appreciate that, Kellen. Yeah, I think the driving point we need to make, especially on the water management teams, is why they're so valuable. And if you really think about it, what they do is they really help streamline decision-making processes as you're going about this program, how a client's going about this program. One of the key words, I think, is awareness. And I'll just give you a quick personal case study with a client that Kellen and myself and others have worked with for a number of years now. And it was interesting. I want to draw back to what Kellen said earlier in the presentation about listening to a lawyer one time during a professional organizational talk. And he was talking about how 30% of cooling towers or cooling water systems within an organization, you might find 30% Legionella. And as Kellen said, when a well-managed program, that's not entirely true. But to give you some real facts and to actually give you some real data, We're working with a client. This was a healthcare system. It was spread among numerous facilities across 4 states. And when they made the conscious decision to go down this process, to actually go down this water management program, and they developed their team, their initial data showed that they were at about, say, 18 to 19% of positive Legionella within their cooling tower systems. And when the team first came together, there was awareness. And the team was diverse. You had facilities people, you had engineering people, you had plumbing people, you had operational people, you had infection prevention people, you had infection control people, you had administration people. And everybody really didn't understand what their actual jobs were within the facility. And what was so unique and so powerful about the team is that by sharing their experiences, sharing what they wanted to get out of the water management program, they started to come together to mutual decisions to streamline the process. And they made a very, very solid program. And over about an 18-month time period, because of that awareness and because of the drive to take control over the program, they dropped from 18% positive hits down to less than 7%. And when you take a look at that from the fact of going across 4 to 5 states, it's pretty significant. And the other word that probably Kel will use later in this presentation is, whatever the water management team does, it's defensible because of the team coming together under one decision. Kellen, I'll throw it back to you.
Thank you, Scott. Next slide, please. So once the water management teams come together, they then go ahead and put together a benchmarking program. And I'm gonna get through this real quickly, but I just want to highlight, any goal is going to be to ensure that cooling or the removal of heat is uninterrupted. But for this, laying out the objectives, the safety, the efficiency, and the cost objectives, and then the KPIs to follow up, really helps keep the team pointed in the right direction and from suffering from paralysis as analysis. So please, when bringing together that water management team, listen to everyone's objectives, and then as a team, bring them all together so that on a quarterly basis, everybody can review them and know, keep score so everyone's on the right track. Next slide, please. Once those key KPIs are formalized, then you want to go ahead and create a performance specification. Now, the performance specification includes products and equipment, process flow diagrams, which are also mandated by ANSI ASHRAF Standard 188, water quality standards, and just so you know, a lot of businesses out there now are checking source and quality of water coming into their facilities, and so it gives them an idea of what kind of quality of water they're getting, when it's coming in, so then they can make the best decision possible for how they want to treat it going forward. Test methodology requirements, water treatment supply requirements, and then a summary of roles and responsibilities, and of course, what happens if something's not met. What this performance specification does is drive standardization and clearly communicates what needs to happen. For example, different parts of your organization may prefer to use different treatment suppliers or equipment suppliers, but the performance spec does allow for this and allows for objective performance evaluations and ultimately conduct an RFP or an RFQ. So you can go out and also hold suppliers to performance. And basically you're just helping to standardize the level of performance you're seeking to have. Next slide, please. Once a performance spec is in place, then you want to go about developing verification and validation strategies. I'm not going to go too deep on what each of these terms mean, but verification is more of a quality assurance function. It's where you're confirming that the program is being implemented as intended, and validation is evidence that the program, when implemented as intended, is effectively controlling the hazards. And this is more of a QC type function. So I just wanted to point out one thing. On the slide here, we have some verification and validation benchmarking screenshots. And on the previous slide in the benchmarking program, we talked about how we're trying to reduce OPEX per cooling tower. And one of the ways to do it is to make sure that you are not spending, to better understand how much you're spending on your cost to treat your cooling towers. And a heuristic that we encourage people to do is to take your total operational and capital expenditure and divide it by 1,000 gallons of makeup water to get an idea of how much you're spending per 1,000 gallons. And This healthcare organization went from 2 at one facility to 11 at another. And what this does is it encourages conversations around how much you're actually spending on your program, and then also where are your cycles at from one facility to a next. Next slide, please. And then, since we're in the 21st century, we have all of this great technology, and now we can go ahead and make this smart. So we can take all of that work that's been done, our benchmarking program, our performance spec, and so now you do all of that, and you bring the key elements such as a cloud-based software platform specialized for cooling water management, standardized system for automatic sensor monitoring, makeup and blowdown meters, secure wireless data communications, and a standardized online service report. So next slide, please. Now the fragmented approach, just as a reminder, this is what it looked like. Next slide. And this is what it looks like now in 2015. Went from 15 suppliers to 3 suppliers. All data is being reported up into the cloud, and then Phigenics is taking a look at it and sharing that information back with Walmart, but it's accessible to everyone. It's designed to Walmart's KPIs instead of the proprietor's KPIs. There's unscheduled audits that occur, a standardized treatment strategy, one equipment package that's uniform across all facilities, and there is a standardized service report on a monthly basis where the treatment and the critical repair suppliers do not get paid unless they enter the data in the format that Walmart needs for their KPIs. Next slide, please. So what are the benefits of this program? Well, it reduced water consumption by 25% per cooling tower, which over the 6 years of the program was 660 million gallons and $4.4 million. And it improved labor operations and increased energy efficiency. It really, and it decreased any amount of tower failures or shutdowns, so no wasted inventory. Next slide, please. After doing all this hard work, though, it's very important that you finish the process by celebrating and communicating success. You know, put it in your responsibility report. You know, share it. You can go to the Smart Water Leadership Summit, smartwaterleadership.com, and watch videos of Walmart speaking about this program. It's been highlighted in Green Biz on EDF, Green Retail Decisions, and now Alliance for Water Efficiency. So take the time to share and communicate success. And these building case studies, by going and doing it, you really get the message out there. And then your opportunity to hear stories like what we heard earlier to reassess and see how you can even improve the existing program. So I just want to thank you, next slide please, for listening. And if you're interested in more information about defensible water safety programs or CapEx, OpEx optimization programs, please give us a call. We'd love to help. Thank you.
Thank you very much. I really appreciate both Denver Water, TERLYN, and Phigenics for being part of this webinar. So now we come to the part where you get to type in your questions, and we already have some, so Jeffrey will go through the list that we have, but if you haven't had a chance to do that, you know, open up the dialog box behind that orange box with the white arrow and give us your questions. While we're just waiting for those questions to come in, let me just remind you that a PDF of this presentation, as well as the recorded webinar, will be posted online at the link indicated there. It's our webinars page at the Alliance for Water Efficiency. And you can also learn more about the showcase companies and special offers for AWE members at the link listed on our website. So with this, I will turn it over to Jeffrey, who will indicate where the questions have come from and to whom they're addressed.
Thanks, Marianne. The first question right off the bat is general. So the question here is, can recycled water be used in cooling towers? Anyone?
Yeah, this is Rick at Denver Water. We have currently, hello, can you hear me?
Thank you, yes.
Yes, we can, yes.
Okay, yeah, the Denver Water anyway, we currently have some tower from XL Energy that is using recycled water. I have yet to see it on anything small. We are actually hoping to develop some kind of a program where we can push that along. But right now, I don't see a great deal of it in our recycled water. At least our type of recycled water program that we use.
Thank you, Rick. Appreciate that. If no one else has any other comment on that, then I'll go to the next. Rick, for you, how did you develop the 50,000 gallon a year requirement when you were?
Well, like I said, we were just not getting enough response with the higher criteria, and we just we wanted to get as many towers involved as it felt like we were missing out on a lot of opportunities rather than going for the the big one right off the bat. Even if we can just get a lot of the smaller towers involved, it could add up to just as much as a large tower. So it just really worked out, and it has seemed to get us a little bit more activity in our program, and I wanted to get even larger. Right now, while the pay is good, I know some other programs, like for instance California, where they only pay $3 per 1,000 gallons saved. For us to still paying out $18.50 per 1,000 or around $6,000 per acre foot of water, it's still quite nice. So who knows how long that will last, but we are trying to get the word out there more and more, and hopefully we're successful. Every year it's growing.
Thank you, Rick. Next question is for Sean at TERLYN. Does the TERLYN system require any major retrofits to the cooling tower system, or is it simply a change in the chemicals used?
Yeah, and for that, I have Terry Rushmore, who's the president of our company and one of the major developers of the program. I'm going to toss that question to him.
Good afternoon, everyone. The program itself is pretty simple. One of our main goals is to maintain the KISS principle, keeping things as simple as possible. Depending on what is currently being used in the cooling tower system, some equipment may need to be converted to more effective equipment for our program, but typically the program can be put on a cooling tower without any major changes in the equipment or procedures.
Thank you for that. Also, someone just inquiring of the cost of your program.
Well, that's one of the nice things about this program, is that when we look at it as a program, not just as a commodity where you're buying water treatment chemicals. As a program, we look at the entire process that occurs, and that process includes the savings that are generated by the conservation of water. What we have found is that in virtually every situation, the savings generated by the program will pay for the program itself. So in essence, the cost of the program is zero net to the customer. Oftentimes, because water and sewer costs are so high right now and continuing to rise, they will show a net benefit of savings after the program's been paid for.
Wonderful, thank you. How much, for TERLYN again, how much does the hardness of water supply, i.e. groundwater versus surface water, affect your product?
Well, the hardness of the water, of course, is the main consideration in what's happening with any water treatment program. There's a variety of different means that we utilize in order to combat that. So depending on what the water quality is in the area would determine the type of program that we put together. The bottom line is pretty simple. We can handle virtually any water quality that is out there. We have programs running throughout the entire country, and we're dealing with water as good as a couple grains, which is 20 or 30 parts per million, all the way up to waters in area that are in excess of 400 and 500 parts per million. We are based in Florida, and our water here typically ranges between 150 and 350 parts per million.
Okay, thanks. Again, on the program here, have the results of the GSA's Green Proving Ground study on your system been published yet?
That's the biggest question of all. We've been working with GSA and with NREL on this report. The report, of course, is a third-party report through NREL, which is the National Renewable Energy Laboratory. There have been a lot of things that have occurred over the past about 4 years now that the original trial had been done. And every time something new comes up, they find out, more advancements and more benefits, and they want to go back in and add these to the report. So the bottom line is no, it has not been issued or submitted yet. We know that it is very close. The answer that we keep getting when we try to get them to nail that down is simply, understand we are the government and it moves slowly. So unfortunately, no, that report has not been released yet, but we do anticipate it coming up hopefully by the end of this year.
Okay, thank you. Question here for TERLYN and possibly Rick. Did you actually work with the energy utility in Denver to determine savings? Were they receptive? Do you see a nexus between water utilities and energy utilities actually working together? In this person's short experience, they found that it's not very easy to work with the energy utility.
No, I don't imagine that it is. No, we did not work directly with the energy utility. In fact, TERLYN as a company didn't work directly with any of them because it is our technology, and therefore it was left as a third-party evaluation. We didn't want to have a part in that because we wanted it to be unbiased. We do, however, understand that the initial concept of this test was for water conservation. It really hit 4 points. It hit system integrity, which is controlling scale, corrosion, and biological, and water conservation on top of that. The energy savings that were generated by the efficiency of the program weren't identified until after the program had been on for some period of time, and it was almost by accident that they recognized that their systems were running more efficiently and their energy consumption had dropped significantly. But no, we had not worked directly with the utilities on that.
Thank you. Does your product affect discharge water quality, and if so, in what way?
The discharge water quality, no, we don't really have a major impact on that. There are some elements in the water because we are increasing the cycles of concentration and therefore increasing concentration of elements in the water that will change in the discharge water. But as far as the water itself, we have worked with a number of wastewater utilities. We have had them evaluate the discharge from the cooling towers, not only from the level of elements, but also from the chemistries that are being used in there. And to date, we haven't had any problems whatsoever. In fact, most of the utilities will let us know that they would rather see what's coming from our towers than a lot of the stuff that they're forced to take.
Okay, thank you. This question is more so for Phigenics, but others might have a comment. What do you recommend if you don't have a lot of cooling towers, i.e. you are only one site, so you don't compare, or you don't have a larger number like Walmart?
I guess the question probably goes back to the heuristic as far as the water treatment cost. This is not liking me today, but I'll work through it. What we normally see out there, and this is based on a lot of our team having many years of water treatment experience, is that if you take the total capital cost and program cost on an annualized basis, and really the OPEX side of it, and you divide the total water treatment divided by 1,000 gallons, you'll probably see you should see anywhere from about $1.5 to $3. Now this is dependent on the facility as well. So is the contract primarily more service heavy, or is there a large need for chemical? So you could go, I would say a nice benchmark depending on the larger C&I marketplace for universities, healthcare is probably somewhere in that $1.5 to $3 per 1,000 gallons for water treatment.
Okay, thank you. For you as well, Kellen, and maybe Scott, are there any good ways to deal with silica in incoming water? There's been a very challenging in some systems. Any ideas can be helpful?
I'll let Scott answer that one.
answer that one. You did.
Yeah, there are. The first thing you have to do, there's a lot of variables when you're dealing with the makeup water quality. I'm sure Rick and Sean can attest to this too. The first thing you have to do is look at exactly what your incoming makeup water consists of. You know, obviously silica is a big one. The other gentleman talked a lot about hardness too. I think there's a couple of other things that you have to throw in there to make sure you get a good overall picture. And please go ahead and add anything if you think I might have missed it. I think iron is a big one. Here in the Southeast, for a number of reasons, we see a lot of iron in the system just because of the age of the water distribution systems that are coming into the HVAC cooling systems themselves. And that's something that's not actually looked at a lot. And especially within cooling tower systems, as you begin to try to conserve water, cycle up a system, you know, you'll see iron will actually drop out, go to the hottest parts of your system, and cause you a lot of troubles that you otherwise normally wouldn't want. I also see not only silica, iron, and hardness, but also the conductivity or total dissolved solids that's coming, you know, from the city itself. I can tell you that if you go from North Carolina to South Carolina, you can see a tremendous difference in the incoming conductivity coming from the city. So that's another thing that you have to go ahead and make sure that you're aware of. What was alluded to before, especially here in the Southeast, water is relatively cheap. It really is. So, you know, you look at water conservation and things, you got to vary how much you're going to save in water to how much energy costs and electrical costs you might be increasing because you're dropping stuff out of the system.
Okay, wonderful. Thank you. Just another question here, just generally for everybody. Can you comment on nozzle options and maintenance in cooling towers? Open to anyone.
Yeah, I'll take a whack at that. You're talking about the mechanical side of the cooling tower now. One of the things that we pride ourselves in when we service our own systems is that we not only look at the chemical side of things and how to maintain the cooling tower, but we also like to look at the mechanical side of the cooling tower to make sure that it's operating efficiently. When you're talking about the nozzles in the cooling tower, there are several different types of cooling tower designs, but the ones that are probably most common, which is like a Marley cooling tower, for instance, where you'll have a hot deck on the top of the tower where you collect the warm water, and then the warm water is distributed down through the fill material through these nozzles. The flow rate of a cooling tower is determined by how much water you pump through the tower and how much water is allowed to flow down through the fill material. It is very important to understand that cooling towers are designed for the maximum efficiency with specific amounts of water and air flowing through them. As a rule of thumb, the cooling tower is designed to have 3 gallons per hour per ton of flow rate through the tower. If your tower is not flowing at that rate, you're not going to get the maximum efficiency from the tower. Another thing that's important when we talk about the flow of water through the tower, and this is where your nozzles will have an effect on that, is that not only are you carrying the water treatment chemicals in the water, which need to have good flow over the system to do their most efficient job, you're also cleaning the tower from the airborne particles that are brought in. Cooling towers are fantastic air washers, and everything that's being drawn into the cooling tower is being flushed down through the tower in the water stream. So if you have a good solid water stream, you're going to be able to flush that contaminants down to the base of the tower, and it will help keep your tower cleaner.
Anyone else comments on nozzle options, maintenance, and cooling towers? No? Okay. Last question I have here is relating to TERLYN's program, again regarding actual costs, not net costs. Can you speak to that, Sean?
Yeah, I mean, when we look at the actual cost of the program, again, depending on who we're comparing that to, there are a lot of companies out there that are treating cooling towers, and a lot of them doing a very effective job. I would say on average we are in the mid to upper range from a cost standpoint. Our technology is not inexpensive. We developed this technology for very specific reasons, and maintaining complete system integrity along with water conservation was our primary goal. You know, again, we don't like to talk about the product as a commodity, but if we look at a relationship between costs of programs, a lot of times people will break those down into the cost per ton. We've seen some low-end products that are as low as 50 to 60 cents per ton. Some of the major companies will see in the $1 to $1.25 cents per ton. We're typically in a $1.25 to $2 range per ton if you're looking at just the straight cost of the product. But keep in mind that you have to balance that against the return when we talk about the ROI. And again, you know, it's very, very rare that our program will not cover the cost of the program and leave some additional utility savings for the customer.
Thanks, Sean. I believe it was you who just had mentioned in your maintenance question there, or answer, about recirculation rates, and someone asked if you could just repeat the metric that you had noted for recirculation rates.
Yeah, cooling towers are designed with the capability of maintaining a 10-degree delta T. That's a 10-degree temperature differential between the water that comes in and the water that goes out. That is its maximum. It's also designed to operate at a 3 gallons per minute per ton flow rate. And this is the circulation rate of the water through the cooling tower. Now, depending on the type of system that you're operating, you may also need to take into consideration the secondary equipment. If your cooling tower is for comfort cooling, for instance, and you have a chiller system that's involved, oftentimes the cooling tower and the chiller are not properly matched from a tonnage standpoint. If that's the case, you should always look at your chiller and make sure that the operating parameters of your chiller are capable of being handled through the cooling tower. Again, the 3 gallons per minute per ton flow rate is the same for the chiller. So if you have a 1,000-ton chiller, you should have 15 gallons per minute flow rate through your tower. As long as the tower can handle that and is not grossly oversized, you'll get good efficiency from the tower.
Okay, I think that's all we have for questions, correct, Jeffrey?
That's correct.
So thank you to our speakers who were wonderful in their presentations and the answering of the questions. Thanks to all of you out there who've hung in through all of the question period. We appreciate your support of our webinars and our training programs at the Alliance for Water Efficiency, and we encourage you to go and check out the PDF and the webinar. We'll clean up the little technical glitch in the middle. We'll edit that out so you won't have to listen to that all over again. But we will be posting both the PDF and the recording very shortly. So thanks to everybody for participating. Watch for future webinars coming from the Alliance for Water Efficiency. We'll have a very busy 2016 schedule, so stay tuned.